Okay, so the next part in finishing your planning guide here is we need to fill in all of the element IDs, right? So it says to do this before you code, and you can, right? You can go through when you designed everything, right? And put little arrows and what name you want all of these to be, and then make sure when you're building your screens that you name them that. That's up to you, that's fine. Nothing wrong with that approach. Here, I'm just gonna go through all the names that I created, right? So I'll start on the home screen, kind of top down, click this first thing. So what is my element's name? It's the home screen label, right? You can just copy and paste that in there. What type is it? It was a label, right? That's what I dragged in. And we're talking about the type. If you think about when you're in the design here, right? Was it a label? Was it a button? Was it a text area or an image, right? That's pretty much, or a drop down, right? Pretty much all we were using here. So that's what it means there. And then what does it do? Displays the main title of the home screen. Okay, home screen image, that's this coaster here, is an image, displays an image of a roller coaster on the home screen. Home screen text is a text field set to read only, right? Or text area, I think is what it was called, right? Double check that, but I think it's text area. Yeah, so we'll refix that, text area, which is set to read only. It displays the text to be read by the user, so they know what's happening, right? Set to read only. Least button, that's down here, is a button, navigates the user to the least screen. Greatest button, the button navigates user to the greatest screen, etc. Right? So I've done everything on my home screen. Let's go to the least screen. At the top, I've got my least screen label, which is a label, displays the title of the least screen, my least screen image. You get the kind of the idea here. My least dropdown, which is a drop-down type, gives the user options to input and find the least, speed, length, etc. of roller coasters. I know part of this is off the screen here. Anyway, you get the idea. So go through and make sure that everything is listed in here, what type it is. These are text areas. Text area. Okay, and I think all these names match and what they do. So you want to fill that in for all of your elements. This is why I don't get too crazy, right? Adding too many elements. Make it look kind of nice, but don't go crazy, right? We don't need 16 images on there, etc. Okay, then it wants us to fill in our conditionals. So anything like an if statement, right? A Boolean expression is something that evaluates to true or false, like, is this greater than this? Or is this equal to this? Right? So the main ones that I use here is if the sum statistic is greater than or equal to our maximum, replace the maximum with the current stat, etc. Right? So this is pseudocode or just code in words here, right? The notes, this is used inside of a for loop that traverses the appropriate list. So I've included a second one there. There are probably a few more if-then statements in here. I don't think you have to list all of them as long as you have a few of the major ones here, right? We did have some like if it's equal to length, set the units and get the correct list, store it as list to reduce. Our for loop, so I've just copied and pasted in one of our for loops here. And our notes is it traverses the matching list that the user has selected from the dropdown to look for the greatest max value. And stores the corresponding, let's make this bigger here for a second, the corresponding coaster name, park name, city, country, city and country the coaster is located. I'll just say and country, right? Stores those all. Okay, then it wants our on events. Well, we had a few on events when we look back in our code. We had all the on events for our buttons, so there's 4 of those for buttons, and then we had 2 for when our drop downs were changed. So I've included all of those here, and the least home button is clicked, takes us back to the home screen. That's the one from here, the least, oops, that's called the least screen home button. Greatest screen home button. When that's clicked, set the screen to the home screen. Least button takes us to the least screen. Greatest button takes us there. The greatest dropdown is changed. The app will get the user selection if valid. It will find the greatest and update the selection rate. Our functions, These were some examples here. Looks like I haven't finished filling those in. Okay, so we're looking at the functions and how it works. So we had two functions, find least. How does it work? We can move this over probably. It updates the least text output with the info of the coaster with the least of the user's selection, right? So how does it do that? How it works? It will check if the user's drop-down selection equals something valid, like heights. If so, sets the reduced list to proper data column heights, changes the units to the proper units, goes through the user selected list or array, compares each element to reduce the list. This is very key wording to get high points here. Reduce the list and traverse, right? So instead of goes through, let's say it then traverses. Ooh, I love that wording. The user selected list or array, and stores the minimum corresponding coaster name, park, city, and country. It creates an output string and sets it to the least text output. Okay, so similar idea for find the greatest, right? Does pretty much the same thing, but for greatest. So I might update this a little bit down below. But that's an excellent explanation, right? I probably may have been more concise, but it does do a lot of things, right? So one of the things we could have done in our program, we could have made extra functions, but we tried to keep it to these two. So there was some repeated code, which means, yes, we could have had extra functions to handle that repeated code. But I think this made our program a little bit easier to make. So here's your scoring guidelines. Make sure to follow these. There's a written response. I'm going to go over that in a minute. Our overall project. Make sure that it has program contains the following program constructs that are used in meaningful ways towards the program's purpose. Variables, functions, conditionals, like if statements, lists, we had that from our data set, and loops, our for loops. The app has at least 3 different screens. Yep, I've got 3 screens. All screens can be easily navigated to through the user interface. That's through our 4 buttons. All functions include comments that explain the purpose and how they work. So actually what I just wrote here would be an awesome comment to put above our program. If I go here and put in that comment, for multi-line comments, I guess we can just do this and cut it off. So sets the height to the proper units, and then traverses each element to reduce the corresponding coaster name, and sets this. This is a lot of text, right? But look at that. Great commentary, okay, of what this does and how it's going to do it. Okay, so those are some of our extra points that we'll need from here. Okay, no errors inside of our code. That includes the logic error that we caught, like if the user selected, the drop-down selection that said select as statistics, we fixed that. So we looked for errors and fixed it. All elements have IDs and meaningful names. All of them, including your images and your screens. Make sure you have those. Okay, so let's go through the written response portion. This is also very important. So being able to write about our app. So question 1, provide a written response that describes the overall purpose of our program. Make this a little bigger. This app is designed to inform users which roller coasters around the world have the greatest speed, height, length, and number of inversions, or the least speed, height, and length. It will inform the users of the coaster's name, amusement park, city, country, statistic, and what units the statistic was measured in. Okay, that's it. Don't say, I thought this app would be really cool. I thought it's a really interesting app. Like, don't add in just things that are lots of adjectives, right? We want this to be very straightforward. This is what my app does, right? This is what the app does, and users, right? Try not to use me or my or I in this part. Question 2, insert screenshots of 2 program code segments which contain a list being used in your program. This program code segment should show how data has been stored in a list. So we can go back to our code. Right up at the top, here's where we're getting and storing lists from our data set. So we can do a screenshot, Windows Shift S on Windows computers, and then create a rectangle around where we're getting our variables. Okay, so that's now on my clipboard. I'm going to come back in here and just hit paste. Okay, there we go. The second program code segment should show how the data in the same list being used, such as creating new data from the existing or accessing multiple items in the list. Okay, well, ours is a little convoluted because remember we put everything in this thing called list to reduce. So I'm going to give them an example here. Like, if it's these things, I'm going to put that in as part of my code. That's probably too big, so let's resize that. Maybe a little too small. And then below it, let's use our loop. Whether or not you have the line numbers in there, up to you. And we can make that much smaller as well. Okay, so now they can see here we stored our lists in list to reduce and then went through and iterated through. So here's some ways that that was used. Write a written response that identifies the name of the list being processed. In this case, list to reduce or heights, identifies what the data contained in the list is representing in your program. So I did an example here. Name of the list, let's say heights, stored in compares to list to compare. So it's easier for someone to understand what's happening here. Data, what data is contained in the list? The heights of roller coasters around the world, measured in meters. How does the list itself manage complexity? So this part is kind of difficult to put into words, but let's go back to the data set, right? Remember this list for heights, it's giving me these 257 different heights and storing them all in one nice variable, heights, right? Which is a list of all of these. So how does that manage complexity? Well, if I didn't have a list, I'd need to create a variable for every coaster, like maybe like Montana Rusa Infantile height is my variable, and store 3. Then I would need Percy's Railway height and store this. Then I would need this, I don't know how to pronounce that third one, but its height 3.3. And I would have to do that for all, I'd have to have 257 variables. And then to compare them all would be crazy. How do I go? I have to do so many if statements. It actually makes traversing that list really difficult, right? So how does this list manage complexity? Well, to store each roller coaster's heights along with other statistics would require a lot of variables and an enormous amount of if statements to compare them, right? To find or reduce our list. Having all of them stored in a list makes it much easier to traverse and reduce, look at those keywords, with a for loop and if statements, right? So we've explained here that if we didn't have a list, we'd have to have a ton of variables and we'd have to have an enormous amount of if statements to compare them. So it's managing complexity by making it really easy to go through and traverse or iterate through our list and reduce with a for loop. Okay, insert a screenshot of a function definition from our program. So we have some very large functions, right, that we had in our program here. I might need to zoom out a little bit here. So let's go to, find greatest. Look at this, it's huge. Function, find greatest. Tons of stuff, right? Oh, the output string's even part of it too, right? Let's get rid of some of these spaces maybe. Okay, so we can see there's tons of stuff in this function. I'm having a hard time even getting it in one screen. Let's get rid of this. And okay, I think we can get it all now. Look at this gigantic thing. Okay, so we can paste that in our program. I know that's huge, don't worry about it. What does the function do? The function reduces a chosen list to the minimum value with a for loop and stores all relevant information. This is basically what we just had in our other sheet, right? I can even use the commentary we used for our least, right? Is essentially what it does. So you're going to describe what it does in detail, how the function contributes to the overall functionality of the program. Well, it basically does half the purpose of our program, right? It traverses a data set and finds the least, oops, maybe I should have taken a screenshot of the least, traversing a data set, finding the least statistic, and reporting the corresponding info back to the user about that roller coaster. Sounds like I really should have just done least here, right? So let's go back and in fact, let's do our screenshot of the least statistic instead. Make sure we get it all in there. We'll just replace that with the least. Okay. And then our comment here, again, can be directly from our other sheet, right? Or this comment, essentially, of what our function is doing. I just want to get rid of these double slashes that were used for comments. By the way, you can also do multi-line comments a little nicer than I did. So there we go. We'll check the user's drop-down selection, etc. Okay. So this is what it's looking for in the written response. If you can, try to use those keywords that they threw at you, like traverse, reduce, right? All of those things they love.